In this video, you'll see how to solve systems of equations by substitution. So this is an algebraic process that we use if we don't want to graph the equations. So one of the first things I'll look at if I want to solve by substitution is I'll see if one of the equations is solved for a variable. And in this case, they both are. Both of these equations are equal to y. So if the top equation is equal to the y, and the bottom equation is equal to y, that means both equations are equal to each other. So I can write this equation. 4x plus 20 equals x plus 11. Now, in order to solve this, I am going to get my x's on one side of the equal sign, and I'll get my constants on the other side of the equal sign. And I find that 4x minus x, that's 3x. 11 minus 20, that's equal to negative 9. When I solve this for x, I find out that x is equal to negative 3. Now, I am not done with this. This is just part of my solution, right? I want to find out where do these two graphs, where will they cross? What's the ordered pair that's the solution? Well, I know they'll cross when x is equal to negative 3, so I can just choose one of the equations, and I'm going to choose this one just because it's a little bit simpler to figure out what y is. I know y equals x plus 11. I'm going to take out that x, put in negative 3 plus 11. Y is equal to 8. These two lines would cross at the point negative 3, 8. You can see on the calculator here, here's the line for y equals 4x plus 20. Here is y equals x plus 11. And this is the point where they meet, negative 3, 8. All right, here's a second example. You'll notice that none of these are both equal to y like in the previous example, but when I look at this problem, I look at this first equation and I think to myself, it's pretty easy to solve this equation for x. So I'm going to do that first. X minus 7y equals negative 10. And I'm going to add 7y to both sides. So I'm just looking at the variables x or y and thinking, hey, is it easy to solve one of these equations for that variable? So x is equal to 7y minus 10. Now remember, this is called substitution. So when I look at this second equation, I'm going to substitute out the x, and I'm going to put in 7y minus 10. So I have negative 3 times x. So take out the x, substitute 7y minus 10. Minus y equals negative 14. Now I just want to solve this equation for y. So distribute negative 21y plus 30 minus y equals negative 14. I'll subtract 30 on both sides. And I'm also going to combine my like terms and get negative 22y equals negative 44. Divide both sides by negative 22. And I find out that y is equal to 2. I found out what y is, but I still need to find out what x is. So I'm going to go back to where I solved this for x. X is equal to 7 times y, which is 2, minus 10. X equals 14 minus 10. X equals 4. So the solution to this system, which I write as an ordered pair, is 4, 2. We can understand what's going on graphically by checking this here. X minus 7y equals negative 10. Here's the line that represents that equation. And then for negative 3x minus y equals negative 14, this line represents that equation. And you'll notice the point where they both meet is at 4, 2. Okay, and so now we want to solve this equation by substitution. I notice in the top equation, it's going to be pretty easy to get y by itself, but just I want you to know that there's going to be something different about this system that we haven't seen yet. So negative 7x plus y equals negative 3. I'm going to add 7x to both sides to solve for y. And I know that y is equal to 7x minus 3. So now what do? I take this 7x minus 3 and I substitute it for y in my second equation. So 14x minus 2 times 7x minus 3 is equal to 4. All right, let's distribute 14x minus 14x plus 6 equals 4. What happens here when I try to combine my like terms? My x's zero out. I'm left with this statement 6 equals 4. This statement is false. There is no solution to this system. So what does that mean? If I graph this, if there's no solution to the system, what should I see when I graph? Let's see what happens when we graph this. Here's negative 7x plus y equals negative 3. Here's 14x minus 2y equals 4. You'll notice these two lines, they are parallel to each other. They are never going to meet. And that's what it means when there's no solution. There's no point on the graph where they will cross. Okay, last example here. I am going to isolate x in this equation here. You could isolate y, it really makes no difference. I find out that x equals to negative y plus 3. I'm going to go back to the first equation, take out the x, and put in negative y plus 3. So 2 times negative y plus 3 plus 2y equals 6. When I distribute here, I get negative 2y plus 6 plus 2y equals 6. When I combine my like terms, my y terms zero out. I'm left with 6 equals 6. Well, this is a true statement. So if there's no variable and we've got a true statement, guess what? There are infinitely many solutions to this system. So there's not just one point where the two lines will cross. There are infinitely many solutions. And of course, let's take a look at the graph and see what that looks like. All right, here is the first equation, 2x plus 2y equals 6. There are infinitely many solutions. When we graph the second equation, x plus y equals 3, you'll see it's the same line. They are both the same exact line, and that's how we know that there are infinitely many solutions to this. And that's how we solve systems of equations by substitution.